Define the addressing mode. Addressing mode is the way of processor identify the location of data or operands needed for an instruction. These are the example of addressing modes. Immediate addressing. The operand value is given directly in the instruction. Example, move 5D0. Register direct addressing. The operand is stored in a data or address register. Example, add D1D0. Address register indirect. The address register point to the memory location of the operand. Example, move A0D0.
So I'll be explaining about question 3. Give example of a M68K assembly program that performs addition of two numbers using at least three addressing modes. So in this question, we're going to be using the three addressing modes that we're going to be using is immediate addressing mode, address register indirect mode, and register direct addressing mode. So for the first one, immediate addressing mode, we're going to use move hashtag 5D0 and move hashtag 3D1, and we're going to load the values of 5 and 3 into their respective registers. So 5 goes into D0 and 3 goes into D1. Then at D1, D0 will make both operands, because both operands are counted as registers. So then at D1, D0 will go into register direct addressing. Then we will copy the result that we get into D2, move D0, D2, and we will minus that with sub hashtag 2D2, and this will be also under immediate mode. Then we're going to go to address register indirect mode. For this part, Leah numbers A0 will collect your data and move it into A0, move A0 D3. So then move A0 D3 will get your first number, and move to A0 D4 will get your second, and in your result will end up being in at D4 D3. In the end, move D3 result will be the place where your data gets stored, and it will be part of the memory. And simhold is the word that you use to stop the simulation in the end. Okay, so this page is where I'll be telling you what is the instruction addressing mode and descriptions are for each instruction. So move.w hashtag 5D0, the addressing mode is be using immediate mode. So that would load every constant directly into said instruction. The next one, at D1, D0, the addressing mode is register direct. So that will mean that the operators, it will all operate between registers, between any two or more registers. The last one is move A0, D3, which is the addressing mode is address register indirect, and it will access any memory that is wanted via pointer.
Okay, now I'm going to explain for question number 4. Give examples. MCAK assembly program that performs subtraction of two numbers using at least three addressing mode. So the ORG$1000 is the data section. In the data section, I already defined three word size values, which is val1, val2, and val3, with the values 50, 4, and 2. Okay, result 2 is a memory space to store the final answer. Next is ORG$2000. ORG$2000 is the code section where the actual instructions are written. So the next is instruction LEA val1 E0. LEA means load effective address. The address of val1 is loaded into register A0. A0 now points to the location of val1 in memory. Next is instruction for move.w hashtag 25D0. This uses the immediate addressing mode. The value 25 is directly moved into the data register D0. So now D0 is 25. So okay, next is instruction for move.w A0 plus D1. Okay. This use address register indirect with post increment. It means take the value stored at the memory address in A0, which is val1 equal to 50, and move it into D1. And after that, A0 automatically increase to point to the next memory val 2. So now D1 equal to 50 and A0 now points to val 2. Okay. Next is instruction for move W A0 plus D2. Okay, this use the post increment mode 2 and it takes val 2 equal to 4 and stores it into D2 and then A0 move to the next memory location which is val 3. Okay, so D2 equal to 4 and A0 now points to the val 3. Next is instruction for sub.w D1 D0. Okay, so now the subtraction start and the subtraction is subtract d1 from d0. So d0 equal to 25 minus 50 and equal to 10. So instruction next is for the instruction sub w d2 d0. Okay, so d0 equal to 10 minus 4 equal to 6. Okay, next is instruction sub w a0 d0. Okay, this using the address register indirect mode. It takes the value that A0 is pointing to the val 3 equal to and subtract it from D0. So D0 is equal to 6 minus 2 equal to 4. Okay. Next is instruction for move dot W0 D0 result 2. Okay. So finally, the result which is 4 is stored in the result 2 in memory location. Okay. Lastly, instruction for SIMHALT. Okay. So here is the stop of the simulation and the final result is 4 stored in the result 2. Okay, that's all. Okay, so here is the addressing mode that I use. Okay, here we have immediate addressing. For example, move.w hashtag 25do and the description is the value is written directly in the instruction. Okay, next is address register indirect with post increment addressing. So for the example is move.w a0 plus d1. Okay, for the description, it get the value from address in A0 then move to the next. Okay. Lastly, address register indirect. For example, sub.w A0 D0. So this use the value at the address store in A0.
Question 1b. A student learned how logical and arithmetic operations are performed at the assembly level using Motorola 68000 processor. The instructor has asked him to explain how basic logical instructions work in practice based on figure 1 below using Easy68K simulator. First question. Describe every steps of assembly language of figure 1 using Easy68K simulator. First, ORG $2000 sets the program starting address and memory location $2000 in EZ68K. Second, move.w hash $4AB7 D1 moves the hexadecimal value $4AB7 into data register D1. Third, not.w D1 performs a bitwise not operation on D1, inverting all bits 1 to 0, 0 to 1. Fourth, move.w hashsign $5E92 D3 moves the hexadecimal value $5E92 into data register D3. Fifth, or.w D2 and D3 performs a logical OR between D2 and D3. The result is stored in D3. Sixth, add.w D2 and D3 adds the value in D2 to D3 and stores the result in D3. Seventh, sub.w D2 and D3 subtracts the value in D2 from D3 and stores the result in D3. And lastly, N marks the end of the program. No further instruction will be executed. Second question. List all logical and arithmetic instruction in M68K assembly language. First, logical instruction. Not.w, perform bitwise not. And lastly, or.w, perform bitwise or between two registers. Next, arithmetic instruction. Add w adds the value of one register to another. And lastly, sub.w subtracts the value of one register from another.
Assalamualaikum dan selamat sejahtera. Nama saya N.Shafiqah dan nombor mencik saya 21 DIT 25F1186. So hari ini saya akan terangkan question 2A. Convert the expression below into an assembly language instruction. So soalan yang diberi 10111111 binary didarabkan DADA hexa and ditambah dengan 1234 okta. Sebelum kita tambahkan, kita kena tukar binary dengan okta tu ke dalam hexa. So kita dapat binary 10111111, kita dapat convert dalam hexa, kita dapat BF hexadecimal, dan untuk yang 1234 okta kita convert ke dalam hexadecimal dan kita akan dapat 29C hexadecimal. Lepas tu kita tukarkan dia dalam penyata ayat balik, which is BF hexadecimal didarabkan DADA hexadecimal dan ditambah dengan 29C hexadecimal. So kita move forward hash hexadecimal BF ke dalam D0, move forward hash hexadecimal DADA dalam D1. Lepas tu kita multiply D1 ke dalam D0. Lepas tu kita add word hash hexadecimal 29C dalam D0. That's all for me.